choosing the right object for the job. So, designed as a simple building block, a replication controller's only responsibility is to maintain the specified number of replicas. A replication controller counts only live pods, terminated pods are excluded. So, other Kubernetes building blocks or objects should be used together with a replication controllers for more advanced tasks. For example, an autoscaler can monitor application specific metrics and dynamically change the number of replicas in the existing replication controller. In addition, a replication controller does not support scheduled policies. Managing you cannot provide the rules for choosing cluster nodes to run pods from the managed sets. And a replica set is another Kubernetes building block. The major difference between a replica set and a replication controller is that replication controllers do not support selectors with set based requirements, while replica sets support such selectors also. From this perspective, a replica set is just a more advanced version of a replica controller. Using only pods and replication controllers to deploy an application is, at least in part, an imperative form of managing software because it usually requires a manual steps. A Kubernetes deployment is an alternative that enables completely declarative application deployment. So here I'm just summarizing everything, whatever we have discussed so far in Kubernetes, from replica set, replication controller, pod, and then deployment. So we have gone through all those things. It doesn't mean every time you have to do pod, you have to create a pod, and after that you have to create a service, and after that you have to create a replica set. No, not at all. Not at all required. The highest object that we have here is a deployment. What does the deployment will do? Using only pods, replicate only pods, either only pods object and only replication controllers to deploy an application is not a good idea, because it is like an imperative form of managing software. You have to give a lot of manual commands. In spite of that, we have a higher object to deal these things automatically. That is our Kubernetes deployment. So Kubernetes deployment is an alternative that enables completely declarative application deployment. You write in a definition file what you have to do, that's all, rest all will fall in place. So the deployment object is gonna look after rest all of the things. So now we will choose the right object for the right job. First, secret. A Kubernetes secret allows user to pass sensitive information such as passwords, authentication tokens, SSH keys, and database credentials to containers. A secret can then be referenced when declaring a container definition and read from within containers as environment variables or from local disk. Then we have a config map. A Kubernetes config map allows users to externalize application configuration parameters from a container image and define application configuration details, such as key value pairs, directory content, or file content. So config map values can be consumed by applications through environment variables, local disks, or command line arguments. Then we have job. A job is used to create one or more pods and ensure that a specified number of them successfully terminate. It tracks the successful completions, and when specified number of successful completions is reached, the job itself is complete. Then daemon set. A daemon set ensures that all or some nodes run a copy of a pod. A daemon set tracks the additional and removal of cluster nodes and adds pods for nodes that are added to the cluster. So terminates pods on nodes that are being removed from a cluster. Then we have a namespace. A namespace provides a logical partition of the cluster's resources. Kubernetes resources can use the same name when found in different namespaces. Different namespaces can be assigned different quotas for resource limitations. Quota sets resource limitations such as CPU, memory, number of pods or services for a given namespace. It also forces users to explicitly request resource allotment for their pods. So with this, we have come to an end of everything Kubernetes. So here we have gone through the history of Kubernetes and Kubernetes high level architecture, and we have seen the differences between traditional deployment, virtualized deployment, and container deployment. Then we have seen the benefits of the Kubernetes. Then we have entered into the cluster architecture and we have explored each and every component of cluster architecture theoretically as well as practically. So then Kubernetes API we have seen. Then we have nodes. We have discussed about the different nodes. Then high level architecture, then controller types such as replication controller, replica set, deployment controller, then cloud controller manager, then container runtime interface, garbage collection. Then the most important concept is to differentiate imperative versus declarative orchestration. That also we have seen theoretically and practically also. Then we have entered into the most important and highlight of this part. Our highlight of this video is working with Kubernetes objects, specifically working with each and every object. That's what I have done it, because to differentiate, to remove that confusion in your brains, I have designed this video in such a way that it would be pretty clear, it would be cakewalk. You may think, if you work along with me, you may think that Kubernetes is a cakewalk, bro. So here we have discussed about the KH objects, each object from namespace, pod, service, replica set, deployment, volumes, secret, config map, and we have done 2 to 3 examples. One is imperative way and declarative way, and we have written definition files and we have created respective resources of that object. And finally, we came to the cheat sheet. We have looked into the cheat sheet of kubectl, and then finally we have seen a way to choose a right object for the job. So with this part of video has been completed, wrapped up. Now I'm gonna see you in another part of Kubernetes video, that is basically hands-on Kubernetes. Of course, here also we have did huge amount of Kubernetes exercises, but there we'll be specifically working on 2 mega projects. One is using Minikube and other one using kops and kubectl. I will see you there. Until then, bye bye. See you. Keep subscribing it, keep liking it, keep loving it, keep spreading it. See you again.